Alright, so Unit 8, Skill 7. What formulas are used with exponential growth, decay, and what do the parts represent? Kind of important that you understand all the different parts to it. So we have our f of x equals a times b to the power x. A is going to stand for your initial value. Okay. It's also called the y-intercept. Or some people call it starting point. It starts when x equals 0. Okay. Your b value, all right, that is your growth or decay rate. Okay, sometimes it's called the multiplier. Okay, sometimes called the multiplier. So let's take a look at some problems. You've seen a lot of this. This is pretty much review from 8th and 9th grade. So, first problem, we're looking for our initial value. That's when x equals 0. Now you can actually plug 0 into the problem if you want to. If you put a 0 there, anything raised to the power 0 is 1, and you do need to remember that. 3 to the 0 is 1, or at least remember that you can use your calculator to figure it out. So the initial value, when you plug in 0, is going to be 2. Right, the growth rate, the multiplier, okay? It's growing multiplied by 3 each time. Table of values from your calculator, okay? Not extremely important, just copy it down. What we would have, negative 1 is going to be 2/3. All right, 0 is going to be 2. 1 is 16. 2 is 18, and then it really starts to go up. So this bad boy right here is going to be your exponential growth. Okay? Make a quick sketch. Come on. I'm not sure why this isn't working. Again. So your graph is going to be negative 1 2/3. It's going to look something like this. Okay, it's going to cross right here at 0, 2. Alright, it has an asymptote line right here at y equals 0. Dotted line going across, y equals 0. That's kind of what your exponential growth looks like. So, let's jump in and do the next one. Decay. Okay. The initial value when x is 0, again, anything to the power of 0, like 1/2 to the power of 0, is going to be 1. So we end up with 16. Okay, that's when x equals 0. And the growth rate, all right, is whatever is raised to the power. So this is 1/2, the multiplier. Table of values that you would get from your calculator. All right, negative 1 is going to be up at 32. 0 is going to be at 16. 1 is going to be 8. 2 is going to be 4. And 3 is going to be 2. And here comes the music. I hope you enjoy the background music. Alright, so x and y. Didn't label them here, I forgot to. Totally should. You forget to label those, and guess what? You lose credit. So, this graph. Negative 1 is way up at 32. 0, 16. Alright. 1, 8, so on and so forth. This is, I missed my point there. This is exponential decay. Notice that it's going down, okay? So, that's what your graphs will look like. You can kind of tell growth because it is going up, decay because it is going down, just by looking at a graph. Now, the multiplier can be seen inside the table, which is kind of why we do the table. Not so much that you really need a table of values to plot those points. You don't need to write it down. You can just plot the points if you wanted to. But the multiplier is seen here, and it's very easily seen when you go from 2 to 6. You had to multiply by 3. When you go from 6 to 18, you had to multiply by 3. Hence this number up here being called the multiplier. You see it in the next question. When you go from 32 to 16, you multiplied by 1/2. 16 to 8, again, you multiplied by 1/2. Okay? And so on and so forth. 8 to 4, 4 to 2. We're still multiplying by the multiplier, right? Which is 1/2. So that is your decay. All right, so let's go on to the next page. Take a second right now to see if you can fill in the values of growth or decay, the y-intercept, and see if you can figure out what the rate is going to be. So use the previous page, take a look at it, and see if you can come up with those values. I'm going to pause the video right now. You can do that. Okay, so the y-intercept starting value, initial value, or the value when x is 0, all the same. You should be able to notice that it always comes from the number in front that's not being raised to the power. Okay. Growth or decay is totally determined based off of the rate. So if the rate is greater than 1, so if the rate is greater than 1, we are going to have growth. And when the rate is between 0 and 1, so b less than 1 is what we use for the rate, this is decay. So anytime you have a fraction that is between 0 and 1, that is, it's going to be decay. Keep going. So, exponential equations, also modeled in percent increase and decrease scenarios, okay? And those equations are represented by a slightly different formula, although it's kind of the same thing, but we can tell what is the percent increase or what is the percent decrease that's going on. So we need to understand all parts of this, and this formula I don't believe is given to you, so you need to get to know this one, unfortunately, pretty well. So first part, A is the final value, final account value, the total value, all right? It's that final value that you're dealing with. So final, and it can be account value or final, we'll say account. Okay, it doesn't always have to be an account, but final whatever value, okay? P is going to be your starting, your principal, or your initial. Initial amount. Also an investment, okay? Could be your initial investment, okay? All right, R is going to be the rate. It is the percent, and that needs to be in decimal form, okay? A lot of people see 5% and think that you're going to use 1 plus 5. No, 5% means 1 plus 0.05. You have to divide by 100. Okay, you have to divide the percent by 100 to convert it. Most of you already know that. T is going to be the time. All right, in this case, this problem's number of years typically dealing with. Okay. So, if we want things to increase, we have to use the plus. Okay, the plus is going to represent increasing. So if it's a 5% increase, that's what we're doing. This would be growth. We add it. If it's a 5% decrease, we use minus. All right, that is for decay. So, take a look at these two problems that we have here. We have f of x equals 200 times 1.2 to the power x. The initial value is still the same. It's the number that's not being raised to the power. It's a number all by itself there in front. That would be 200. But the growth rate, okay, and it says growth rate, so it kind of gives it away, but it is a growth rate, all right, is going to be how far above 1. So if you look at the equation that we have up above, the rate, R, is what's above or below 1. So the percent increase in this time, in this question, is actually 0.2, which is a 20% increase. So from 1.2, what is going on here? So 1.2 minus the 1, sorry about that, will give us 0.2. Multiply that by 100 is a 20% increase. The next question, the initial value, again, is the starting amount, number in front, so that's 1,000. And the decay rate is how far you are from 1. So a lot of people are going to say 0.7. If it's a multiple choice question, that will totally be an answer. We don't want to use that. 1 minus 0.7, all right? is going to give us 0.3. All right, so we have a 30% decay rate. Multiply it by 100. Okay, so 30% decrease. Moving on. Let's do a couple of questions and then call it good. So, example 3. If the amount of money in a savings account can be modeled by the equation A of t equals 250 multiplied by 1.045 to the power t, which of the following is true? So, the initial amount, your starting amount that you must have started with, okay, has to be 250, right here. That's your starting amount. So we can ignore that guy and that guy because it says $2.50, which doesn't make a whole lot of sense. When we plug in 0 up here, we can see that we'd get 250. And then it says the interest earned is. So what is the interest rate that we're going to have here? Is it 45, 4.5? Which one are we going to go with? Well, we have to do 1.045 minus the 1, and that's going to give us 0.045. We take that number now and multiply it by 100, and it gives us 4.5%. Okay, so we're interest rate of 4.5%. That's how much we are earning out of it. So we're going to go with choice 3. So take a second right now and see if you can come up with the starting value, tell whether it's growth or decay, and what is the rate. Are we increasing, decreasing? So you go ahead and try that. I'm going to pause it right now. Okay, so first problem, again, the y-intercept is always going to be your first number there, so the 400, the 5,000, and the 100. The rate is found by figuring out how far you are from 1. So 0.85 is 0.15 away. Multiply that by 100 to get 15%. 0.3, or 1.3, I'm sorry, is 0.3 away from 100, so 30%. And 0.95 is 5%, or 0.05 away from 100. So any number that is above 1 is going to be growth, so that's why this guy is the only one with the G. And then any number below 1 is going to be decay. Alright, I think we have 2 more questions to do here. Alright, since January of 1980, the population of the city of Brownville has grown according to the following model, where X is the number of years since January. What was the population of Brownville in 1980? Is the population increasing or decreasing, and at what rate? So they want to know the population to start. That's when time is 0. There's 0 years since 1980, so we're going to plug in 0. It's pretty straightforward. With a 0 right here, we would end up with 720,500 is the population in 1980. Is the population increasing or decreasing? Now we take a look at the multiplier, the number inside parentheses. That is 1.022 minus 1 is going to give us 0.022. That is how far it is from 1. It's above, so it is increasing. And at a 2.2% rate, or per year. Okay? There we have it. Question 2. You drink a beverage with caffeine, and each hour the caffeine in your system decreases. Makes sense, your body's filtering it out. The amount of caffeine in your body is modeled by the equation caffeine equals 120 times 0.88 to the power t. How much caffeine was in your drink, and at what rate is the amount of caffeine decreasing? So, starting amount is when you plug in 0. That's also the number right in front. So 120, we don't really know, maybe milligrams, I don't know, is the caffeine. Okay, caffeine to start. And it is decreasing. Alright, so how much is the decrease? Well, it is decreasing what? Well, 0.88 is how far from 1? That's 0.12. So 0.12 is the number. That means it's decreasing 12%. And it is each hour, so it's 12% every hour. All right, so don't forget to make up your summary and your practice problems. Thank you.